Good morning, my dear followers and subscribers. I'm starting a new course on time series for those who are beginners in time series analysis. The first video that I'm going to present here is that I'll discuss various properties of the time series. So let me start with the introduction and the time series analysis may be a univariate analysis or a multivariate analysis. For the time being, I take start with the univariate analysis in which we are dealing with one series at a time. And the second point to note is that there are two general classes of the processes of the time series, and I'll discuss that in detail later on. And regarding the understanding of the behavior and forecasting of a time series, we may use both science as well as art. And later on, we will assess and test the behavior of the time series. If you look at this figure, there is a time series which varies with time, and there is a downward trend in this, and this time series has been generated as a draw from the stochastic process. So each of the point of time series associated with the various units of time is associated with a probability density function or probability distribution function. For example, this is the probability distribution function associated with yt values of the series. This is the probability density function of the time series associated with yt plus 1 and so on. And these red dots, some of the dots are below the line and some of them are above the line. These are the actual realization of the stochastic process. So the time series are one draw from the stochastic process. Now regarding two different classes of processes, we may discuss stationarity and non-stationarity. The question is, what do we mean by stationarity and non-stationarity? You might have noticed in the earlier slide that the probability distribution function remained unchanged over time. And you may look at this. Here in this diagram, the probability distribution function remains constant over time. So if this is the case, then the time series is known as stationary. But if the probability distribution function changes over time, then the series is known as non-stationary. And we may also be using various procedures to test for stationarity of the time series. And we may use the less stringent form of stationarity, which is known as covariance stationary. And under covariance stationary, the unconditional mean and the unconditional variance remains the same. For example, expected value of yt is equal to expected value of t plus j, and that is equal to the constant mu. Similarly, the variance of yt is equal to the variance of yt plus j, and that is equal to sigma square y. And the covariance depends on time j that has elapsed between observations, not on the reference. So covariance means that the two observations vary with each other but their covariance depends upon the difference of time between the two observations. That is, the covariance between yt and yt plus j is equal to the covariance of ys and ys plus j, and that exclusively depends upon the time difference between the two observations, and that is why the covariance of yt and yt plus j and the covariance of ys and ys plus j is equal to gamma j. So it means that the covariance between two observations depends upon the j, which is the time, which is the difference between the two time period. Here there are four figures, and you may guess whether the distribution of yt as function of yt is stationary or not. So you may think for a moment, and then you can decide on your own whether it is stationary or not. So we start with the first figure, and if you look at this, this is the probability distribution function, this is the time period t, and these are the various values of y. So if you look at the spread or the distribution of this function, so it remains constant and the mean also remains constant. So definitely this series, that is the yt series, is stationary. But in figure 2, the variance does not remain the same, it changes over time. Similarly, in the figure 3, even the mean changes over time, and here there is some oscillation regarding the distribution of yt as a function of t. There is some oscillation. So the first figure shows that the series yt is stationary, but in the remaining three figures the series does not uh, follow stationarity, it is non-stationary. Now the question is how to understand the behavior and forecasting of a time series. So regarding this question, the first question which may be asked is whether a series, whether a y series is stationary or not. If it is stationary, then we may use alternative models, and we may choose the best ARMA model, that is autoregressive moving average model. And once we choose the best ARMA model, then we can use that for forecasting. But in time series data analysis, in majority cases, the time series are not stationary at level. So we may need to transform the series either by taking the difference, or by taking natural log, or by taking growth of that series to make it stationary. And then we can assess and test for stationarity if it is not stationary. So if it is stationary, as I mentioned earlier, we will find the best ARMA model, and regarding the choice or the option of the best model, uh, science and art is involved. And after that, we may use some diagnostic tests for the best model under consideration. And under diagnostic test, we are checking normality of the residuals, autocorrelation, serial autocorrelation of the residual term, and heteroscedasticity. And after that, we may use that model for forecasting, and we also use diagnostic test for forecasting for the model that we use for forecasting. And after forecasting is made, we use these diagnostic tests. On the other hand, if the y series is not stationary, then we may transform the data, and one of the methods of the data is to use the unit root test, and we have different unit root tests like augmented decay Fuller test, Phillips Perrin test, and there are some other tests as well. So here is the outline, and we are discussing the part first of stationary processes. So we need to have identification, and we will discuss that how to identify, and then we will estimate and select the best model, and later on we will put it all together. We may use simulated data or the real world data, and then we may also discuss the non-stationary processes. We may characterize whether the time series is stationary or not stationary. If it is not stationary, then we may be using various tests that I just discussed. So ladies and gentlemen, thank you very much for your attention. If you haven't yet subscribed to the channel, kindly do subscribe, and click on the bell icon so that you can get valuable information about my new videos that I'll upload for you. Thanks for watching the channel and this video. You may share the video with your friends, with your colleagues, with your students, so that they can also get benefit of this. Thank you, and see you in another video.